back to tangent, we're going to practice solving for different variables using the tangent equation in these examples. So in this example in your notes, you have to find x to the nearest hundredth. There's another problem in there that I want you to cross off because it's not set up for tangent. So let's start with the angle. We have 25 degrees. We want to set up the ratio to be opposite over adjacent. Now this equal sign in the middle is really important because if you don't have the equal sign, you don't have an equation. People like to forget the equal sign, but it's important that we add it in. Tangent of 25 equals the opposite over adjacent. In this case, the opposite is x, and the adjacent is 18. The base side down here, the flat side, is actually the hypotenuse, which we're not going to use. We want to get x by itself. That's the key here. We need to solve and isolate the variable. So one thing we can do is multiply both sides by 18. If we do that, watch what happens to the denominator. Watch what happens to the 18 on the side. They cancel out. So now you're left with 18 times tangent of 25 equals x. Well, here's x all by itself, which means this is what we need to enter to our calculator for our final answer. You're going to enter it exactly the way you see it. The 18 cannot multiply inside to the 25. Remember, this refers to the tangent ratio of a triangle with a 25-degree angle. This tangent of 25 is its own unique number, and that number is multiplied by 18. When you enter that into the calculator, 18 times the tangent 25, you should get your final answer. And that answer is approximately 8.4. So now you're going to practice solving the next two problems. Again, the same way, set them up and solve them on your own. You can pause this and the solutions will show up when you're ready for them. So now that you've solved them, your solution should look something like this. Tangent of 27 equals x over 10, opposite over adjacent. Multiply both sides by 10. 10 times tangent 27 should be approximately 5.1. Very similar setup in the next one. Tangent 25 equals x over 10, opposite over adjacent, times 10 on both sides. 10 times tan of 25 is approximately 4.7. The next few questions, or the next only question, is set up a little bit differently. What if x is in the denominator? We can still solve for it, but there's a different strategy that we should try out. So let's set up the equation. Tangent of 47 equals 19 over x. 19 is the opposite side, x is the adjacent side. Well, we need to get x by itself, but x is in the denominator. So we can't multiply by 19 again, like we did in the other two problems. That's not going to get rid of the 19 in the numerator, and it's not going to get x out of the denominator. We need x in the numerator, so what we're going to do is actually multiply both sides by x. This will eliminate the fraction on the right side. If we go x on both sides, those cancel out, and we're left with x times tan of 47 equals 19. This still isn't good enough because x still is not by itself, but since we're multiplying x and tangent of 47, we can divide by tangent of 47 to isolate the x. Tangent of 47, remember, is its own unique number. So if we divide both sides by tangent of 47, they cancel out on the x, on the left, sorry, they cancel out on the left and leave x by itself. So now x equals 19 divided by the tangent of 47, which is a number. It's approximately 17.7.